So at any rate, a boring presentation. I realize some of you probably think, oh my goodness, this is what I'm going to expect for today. And that's not exactly what I have in mind, of course. What I want to talk about is this possible link between emerald ash borer and ambrosia beetles. Now, this is not based on research, and I want to stress that. Unfortunately, we've not had the opportunity to initiate a research study to document this relationship. This is based on anecdotal evidence and some speculation. However, I'll share with you what we've seen here in Ohio, and before coming on, Troy gave me a bit of a background on where New York is relative to emerald ash borer, and thankfully there seems to be a large part of the state that has yet to experience the beetle. Ohio, unfortunately, is really becoming overrun, particularly with the western side of the state. You know, with Toledo being so close to the point of introduction in a Detroit suburb. But, you know, it appears that we had multiple introductions, perhaps years before it was discovered in Detroit. So that accounts for, and I think Troy indicated that, that maybe in the Catskills of New York that it actually appeared there before the western part of the state. So that's kind of what we're dealing with, the pop-up aspects. Well, tree borers and tree health, and this is just kind of a bit of an overview of something that I actually shared, I think, the last time I made a presentation. It has to do with this idea that all tree borers are not equal, and sometimes we do lump them all together. It's very easy to consider, and I would stress, for example, that emerald ash borer and Asian longhorn beetle, for example, very, very different borers. And the same is going to hold true today. So I developed this tree health continuum to sort of connect, okay, where do the borers show up relative to this continuum? So if you look, I'm just using some color codes here to show live and healthy trees, live but stressed trees. You can see there's a little bit of a yellow there, moving into a little bit of a red, dying trees, and finally dead trees on this continuum. The challenge is, obviously, that we don't really have the capability to easily tell when a tree is live but stressed. That part of the continuum is not easily discerned. However, the borers can tell us if a tree is in trouble, because these borers tend to focus on different parts of the continuum based on whether or not the tree can put up a defense. Now, many of you that have a forestry background know very well that as trees become older, mature, for example, in forests, they start losing the ability to defend against borers. Well, the same thing can happen in landscaping as trees get older, but also there's another part in landscaping that we tend to forget. When trees are first planted, we can go through what we call transplant shock, and that is a stress moment. Also, you can have trees that are stressed just because of a drought. So, in other words, they're not heading in a bad direction immediately, but under drought conditions, they can then lose their defense mechanisms and become colonized by borers. I'm putting in motion this idea that our metallic wood borers can go after, depending on species, dying trees, and bark beetles can go after live but stressed trees. Now, I'm also sliding, if you'll notice, you know, bark beetles and ambrosia beetles, very, very similar beetles. They do very different things, though. But again, just to put into motion the idea that I want to make it plain that not all bark beetles just go after live but stressed trees. Some go after, depending on species, dying trees. And the same with ambrosia beetles. So this sliding back and forth is to demonstrate that, depending on the species, these different beetles will fall in a different place on this continuum. The bottom line, though, is the vast majority of our tree borers fall into this live but stressed tree to dead tree category, not live and healthy trees. And this is why we teach the idea that tree health management is, in fact, tree borer management. So, in other words, reducing stress is extremely important in borer prevention. Well, the challenge is our non-natives. And of course, if you notice at the top is emerald ash borer, at the bottom is Asian longhorn beetle. these non-native invasives go after all trees. I have them over with live and healthy trees because the reason being that, as a matter of fact, if you have a healthy white ash, emerald ash borer will find it, go after it. It does not necessarily have a link to stressed trees, although I think many of you know this, and this was started in Michigan, originally to try to monitor for emerald ash borer. Bark was removed, trees were stressed, and there was a slight uptick because, these beetles aren't dumb. They're going to go after trees that lack defenses as well. They appear to have that mechanism, but the overarching point I'm making is that tree stress and host selection by emerald ash borer aren't really well connected, and that's true for many of our tree borers. Well, tree borers and boring locations, a little joke here, like Nebraska is part of the Big Ten now, so we have to make jokes about it. So boring locations, and a little short segue, because I'm going to be using some graphics here that have to do with tree structure and function. Just some basics. This is a review, I think, for probably everyone on the call. So when we look at a cross-section of a tree, we see this outside ring of bark, the next ring phloem. This very, very thin, as a matter of fact, it's only 3 cell layers thick cambium. As a matter of fact, though, I want to stress that this is not, the size of these rings in my graphic aren't exactly the same size that you'll find in a tree. Most times when people pull what they think is the bark off the tree to expose the xylem, they think they're pulling the bark, but they're actually pulling the bark and the phloem off. So that phloem is a very thin ring, and the cambium is kind of a slimy thing. It's magical tissue, though, because those cambial cells divide to become both the phloem and the xylem.
You know what? I don't know that I didn't. Sorry, I was on a webinar.
I'm sorry, did somebody have a comment?
Go ahead.
By the way, we have questions at the end, and I should apologize. I should have mentioned this. Since we do have the ability for anybody to ask, if you have a question, stop me, because I'm moving through kind of fast, and there are a lot of different points here, and holding questions to the end is perfectly fine, except if you're confused, if something doesn't make sense, please, somebody, stop me and say, wait a second, Joe, what does that mean? Because that can interfere with learning. But back to these cambial cells, I describe them as being like teenagers. They just don't know what they're going to be until they grow up. And we do know that those cambial cells are exposed to oxygen. They form an entirely different type of tissue, not phloem or xylem. They form what we call wound or callus tissue, and for you purists, you know that that's not exactly the same, but just for this talk, let's just say, okay, wound or callus tissue. So, for example, if a tree gets hit by lightning, we've all seen this. We look closely at a tree, and we can see that wound tissue trying to close up that wound. That was created by the cambial cells being exposed to oxygen through the damage. And I'm showing a very nice pruning color. This is what we'd really like to see happen, because proper pruning should not remove the cambium. You get this nice donut-shaped closure that's going on. And it's why we teach folks not to use pruning sealer when they prune a tree, because that prevents the oxygen from reaching the cambial cells. But this is an entirely different presentation. Sorry for going on a little bit tangent there, but kind of an important connection. Of course, the phloem is where we see the carbohydrates flowing down and up. And that's very important, because we know that we have multi-directional flow in the phloem. We know this, for example, in the spring when, of course, in New York, for example, big-time areas for tapping into to sap with sugar maples, and we know it flows down because that's where how the tree translocates carbohydrates produced in the leaves. And of course, water and nutrients flow up the tree through the xylem. We don't have reverse flow in the xylem. It goes one direction. All right, so emerald ash borer, some basics about emerald ash borer. It's important to understand that even though I did, show this very, I think complete graphic, when it comes to transport in the xylem, there are different types of trees, 2 different types of trees. There's diffuse porous, which I don't have shown here, where 4 to 5 of the most recent xylem rings are functional. And then we have ring porous trees, such as ash trees, where you only have 1 season's, the most recent year's worth of growth of the xylem that is functional. So only one ring is functional. So if we look at how emerald ash borer does damage, you can see the early instars and late instars are phloem feeders, although you're looking at this and probably thinking, well, I'm claiming they're phloem feeders, except they're causing damage to the xylem. The reason for that's pretty simple. Remember, the phloem is very, very thin. If you take a look at the shot, you'll see this really nice emerald ash borer serpentine mine. What you're seeing, though, if you look to the right, is you're seeing the early instars are not large enough to start etching. And that's important. They're actually not feeding on the xylem. They're etching into the xylem just simply because of their diameter. But as they get larger, they start etching that xylem ring, destroying that xylem ring. And that's an important thing to consider. It's also why woodpecker damage for emerald ash borer, woodpeckers going after the larvae, are very shallow holes because, again, emerald ash borer larvae are phloem feeders. And we see this very dramatic. We're not sure why woodpeckers do this. It's just, actually, I've never seen this with any other borer, this removal of the bark. It's like they just go into hyperdrive. Of course, the eventual damage is you have the entire plumbing of the tree wiped out. You have both the phloem and that first ring of xylem, and this can lead to what we call synchronized death when populations get very high. It appears that a lot of trees are going down suddenly. And so if we take a look at synchronized death on a street in Toledo, I have to tell you, these trees looked very healthy the year before this image was taken. Now, there was some woodpecker damage, but they were totally leafed out, and you can see in 1 year they collapsed, and of course then became very dangerous, because the other part about emerald ash borer and the danger there is that ash trees, after they die, become very brittle. Here's an example I just took last week. An ash tree that was dead dropped, and you can see the main bole shattered. And so you folks with forestry backgrounds know this was always a problem when you drop dead ash in the woods. You'll see this sometimes, this shattering with oaks and maples and the other hardwoods. But ash has always been particularly susceptible to this. So just picture, again, let's go back to this shot. Picture all those trees being very brittle. As I teach often, I hope that car in the background is moving fast through that street. Well, now, all this doesn't happen at once, and many of you have probably seen this before. This is a very common graphic used to illustrate, the population trajectory of emerald ash borer, or as I'm saying, infestation trajectory. And it always starts out, at this very slow linear increase. This is where people may know it's in the neighborhood, but they're not seeing trees dying. Followed by, as populations increase, this exponential increase, where you have a very rapid buildup, very rapid, and heavy pressure starts happening. And this is typically where people panic. That's actually my picture, so that you know what I look like. That's what I look like all the time when I think of emerald ash borer. And of course, this tends to make people, decide they might want to do something else. I'm not sure, but at any rate, it causes great concern. Now, I've put something in here for those of you who are not in an emerald ash borer area yet. Just keep in mind, if you're working with the municipalities or working with anyone, decisions have to be made before this point of moving into exponential increase. Whatever is going to happen, whatever plan, it really needs to happen somewhere in the linear increase phase. That's when things can still be done. Once you get to exponential, it's difficult. And here's why. Within the linear phase, we see emerald ash borer taking years, typically top down and outside in. So each successive year, they move from the top of the tree down, just infesting lower and lower, and from outside in. So during the linear phase, again, trees can remain infested for quite a number of years before showing symptoms. However, when you move into the exponential phase, you can have top-down infestations in one season. The entire tree from the top to bottom hit quickly. And this is demonstrated often by woodpecker damage. Now, these shots were taken in 2012 in eastern Hamilton County. That's just east of Cincinnati. And what you're looking at, of course, is very heavy woodpecker damage. Now, this shot was actually taken in a park And you can see the woodpecker damage all the way down. I hope, I don't know, can somebody tell me if you can see my pointer? I just thought of that. Can everybody see my pointer?
Yes.
Yeah. Yep.
Okay.
Yeah.
So you see, I should have used this earlier. I apologize. So you see this woodpecker damage all the way down here on the trunk flare. This tree had no D-shaped emergence holes. Now, I want you to think about that for a second. We had larvae in one season that came from eggs laid in one season, from the top to the bottom of this tree. With no D-shaped holes, that's telling us that infestation was so high that it was almost like a mass attack. Any of you familiar with southern pine bark beetle? That's what they do. They'll hit a tree top to bottom all at once. And that was really a surprise. We never thought that would happen with emerald ash borer, but of course it is what we are seeing in Ohio. Now, the connection to ambrosia beetle. This tree now is being severely stressed. It's being severely stressed. And this leads to a lot of challenges. As you notice, here's a pathway, and I just took these shots last week. One of our parks, for example, because of the brittleness of these trees, has elected to reduce liability issues by removing the ash that are within wind throw of the trails. So that's helped to answer safety issues. Obviously, too big of an area and not enough money to treat these trees. You know, treatments can work, but in this case, the election was to take them down. It's pretty dramatic, and you can see this. And if you take a look at this tree in the foreground, I'm going to zoom in on it. When another tree was taken down, some bark was knocked off, and you can see why this tree was taken down. If you take a look very closely, you can see all the serpentine mines. So impact can be considerable. This is actually taken in northwest Ohio during the winter. You can see they've done exactly the same thing. And you can see trees infested all the way to the bottom. I throw this in because I like to joke, boy, that's a pretty damaging squirrel, isn't it, be able to take that tree down? But just kind of an interesting little thing. Well, let's get back to ambrosia beetles and this connection. Now, there might also be a connection with bark beetles. And I want to spend just a little time separating ambrosia from bark beetles. They used to both be lumped in the same family, Scelididae. In more recent taxonomy, they are now in the family Curculionidae. For some of you that have had taxonomy, you know that's also what we traditionally, or where we traditionally put weevils. But now both beetles are in a subfamily, Scelididae, and so taxonomy's changed a bit. Both are very small beetles, and they both make very small holes. But how can you tell the difference? Let's go back again to my graphics. And so we're going to just go through a little beetle boring basics here. If we look at bark beetles, just like emerald ash borer, they are phloem feeders. And this is kind of important because I said a while ago, there may be a connection between emerald ash borer and bark beetles, but there's a challenge. Emerald ash borer is also a phloem feeder, so it's destroying the phloem sometimes faster than these bark beetles can take advantage of it. So the competition is pretty tough between bark beetles and ambrosia beetles. Females bore in, they lay eggs in the phloem as they're feeding, and of course then as those eggs hatch, the larvae continue feeding as phloem feeders. This is what it looks like. This is actually, you might think this is bark, well that's the back side of the phloem, and you can see the etching into the xylem. Once those eggs hatch, then you get more holes coming out from the new beetles. Ambrosia beetles, you might notice something that's very different right off the bat. Ambrosia beetles bore into the xylem. They go right across the phloem. They don't pay any attention to the phloem. So here's a female boring into the xylem. It looks like in real life. And as she's boring, she's pushing out behind her a combination of excrement that we call frass and also parts of the tree. And we label this odd appearance of this frass material as frass toothpicks because it looks like toothpicks coming out of the tree. This is what it looks like in real life up close. These toothpicks are very, very susceptible to being knocked off by wind and rain. One rain or a high wind will break them. You can see what's happened here with these frass toothpicks. As they continue to bore, they just keep producing more and more of these. It just keeps coming out of the tree. Now, what I'm showing here is why they're called Ambrosia beetles. The white material in this graphic are fungi. They're Ambrosia fungi, more than one species, and that hasn't been worked out very well as to which species are connected to which beetles. But the bottom line is those females have specialized structures in which they carry the fungal spores, and they inoculate the tree as they're boring. The fungi then colonize the tree. This is what it looked like again in real life. There's the white Ambrosia fungus. There's a beetle right there. The bottom line is that once she lays eggs and those eggs hatch, the larvae do not feed on the tree. They feed on the Ambrosia. Now, I don't know if you can make out this shot. I compressed my images so that they would go faster, but if you look at this kind of rind-like material, that's the Ambrosia fungi, and there is an Ambrosia beetle larva in this gallery. So the point being is a couple of things here. Let me go back. When the beetles complete their development, when the larvae complete their development and pupate, they do not emerge out of the tree by creating their own galleries. Unlike bark beetles, they emerge out so you get more holes. Ambrosia beetles, the new adults actually just trundle right out and go out the same hole that their mother made. So very quick, bark beetles versus Ambrosia beetles. Bark beetles, females make holes going in, so do Ambrosia beetles, but there are no frass toothpicks with bark beetles. Sometimes sap oozes out of the tree with bark beetles. Now, if you stop and think about why that is important in terms of symptomology, it shows you one versus the other. And you might be thinking, well, why does sap not move out with Ambrosia beetles? That's because the Ambrosia beetles are going into the xylem, whereas bark beetles are feeding on the phloem, where we have all these vessels that flow sap. So if you see sap flowing from a tree, it's a bark beetle. Larvae feed on the phloem with bark beetles. Ambrosia beetles, the larvae are feeding on the fungus. New adults emerge, make new exit holes with bark beetles, so you get a lot more holes a lot quicker. With Ambrosia beetles, fewer holes. But both beetles love stressed trees. So if we look at trees under stress, I mean, this is ideal. I put a tree under a road, that's going to be pretty stressed. But trees stressed, and what I'm showing you right now are trees that are infested with emerald ash borer. It is easy to connect the dots here. That tree now is very susceptible to Ambrosia beetles, certain species. These trees infested by emerald ash borer would obviously be very susceptible. So we're heading into rough waters and really can create an issue down the road. So let's just focus now for the remainder of time on these Ambrosia beetles and connect dots with a case study that occurred in 2012. Now, I was called out by a landscaper who had planted 6 Cloud 9 flowering dogwoods in Cornice, Florida. She planted them in an ideal location. In fact, by all indicators, the trees were being well maintained, but they were going through transplant shock when they were planted. 2 weeks later then, after planting, and this is important chronologically, she started seeing frass toothpicks. So 2 weeks after planting, frass toothpicks started appearing. Now, I visited and we sacrificed one, took it down, and there you can see the Ambrosia beetle. I brought the pieces back and put in a little chamber. That's what entomologists do to rear these out. You can see, some close-ups there. It turned out to be the granulated Ambrosia beetle, which we used to call the Asian Ambrosia beetle. It's a non-native. However, I want to stress that everything I'm showing you can also occur not only with other non-native Ambrosias, but even with our native Ambrosia beetles. So 5 of the 6 trees were infested. And here's a question I always ask in my presentations: were the trees infested in the nursery? Because, of course, that would lead to, okay, who's responsible? Well, they weren't infested in a nursery. In fact, I visited the nursery just to make sure, and no, there was no infestation. The beetles arrived from the surrounding woods after the trees were planted, and this gets into the prognosis of this connection between Ambrosia beetles and emerald ash borer. The location for these trees was within about 15 miles, if you recall, that park that I showed you pictures of heavy woodpecker damage top to bottom. So the location was very close to where we had a very high population. As a matter of fact, even within sight of these dogwoods, ash trees were dying rapidly. So the beetles were attacking stressed trees that were already heading for death. And here's a shot of an ash tree located not far from the property. And what do you see coming out of the ash tree? And this is a big ash tree, by the way, probably 30, 35 inches in diameter. Look at all the Ambrosia beetle frass toothpicks coming from that tree. And imagine this tree infested top to bottom by Ambrosia beetles. Imagine the thousands, if not tens of thousands of Ambrosia beetles being produced by this ash tree that is dying from having been infested by emerald ash borer. Don't know if you can see it, but there's a D-shaped hole right there. So this tree was infested and dying from emerald ash borer, and Ambrosia beetles were taking advantage. Look at all the sawdust at the base of the tree. So the beetles were attacking in large numbers, overwhelming these trees. So there's a general rule. Any of you ever worked with emerald ash borer? The general rule is that once the trees become infested with Ambrosia beetles and frass toothpicks appear, nothing can be done. The train's left the station. But there have been some exceptions to this rule, and this is just the very last point I'm making. This is in 2013. It's a Chinese elm, of course, a non-native. However, it's planted at our Cincinnati Zoo and Botanical Garden. You can see there actually, I think there's two, maybe three, but I know two there. If you look closely, these trees had been infested by Ambrosia beetles in 2012. So they were infested the same year that they were planted. They were planted big, they were infested, and the tree somehow overcame it. They responded. As a matter of fact, you can see from the canopy, which I took these shots in the summer, the canopies are very full. So we can't always say Ambrosia beetles are going to be a situation where nothing can be done. And that brings me to the end. I went a little bit over time. I apologize, but if we have any questions, that's the end of the presentation. And then my main point here is just keep in mind, as you are experiencing rapid buildup of emerald ash borer, newly planted trees are going to be more susceptible within the area, and you may get a lot more calls, you may get a lot more reports of high Ambrosia beetle populations, which again can be a real problem with reforestation.